So this video is going to introduce hyperbolic trig functions. So what they basically are is a combination of the functions e to the x and e to the negative x. We're going to add them, subtract them, divide by 2. And we end up with our hyperbolic function. So our sine, our hyperbolic sine is e to the x minus e to the negative x, all divided by 2. And our hyperbolic cosine is adding them. So let's take a look at that and see what it looks like. So here's e to the x. We already know that's our exponential growth. And here is e to the negative x. And so hyperbolic cosine is the easiest one to start with. And so what it's going to do is take all of these y values, so this y value and this y value, and then add them together. So you can see here, this is going to come out to be like 1.45. And so what it does is it forms this. This is our hyperbolic cosine. So as we go through all the x values and add them up, they create this little purple thing here. So you can see they're both positive here, so our cosine's positive all the way through the entire thing because e to the x and e to the negative x are also positive. So that's all it is. So when you come down to here, you can see that's why we end up with 1 here on our cosine, is because that's a half and a half. Each of those is a half. So 1/2 plus 1/2 is 1. So that is the hyperbolic cosine. Now hyperbolic sine is taking e to the x, let's get rid of cosine, and negative e to the x. So e to the x and negative e to the negative x, this one right here. So we're basically taking this function, the red one, and making it negative, which flips it. And then now we have e to the x. And so hyperbolic sine is adding those two together. So if we add them together, we end up with that function right there. So you can see right here that would be 0.5, negative 0.5, so together they make 0. So it's just adding them together, and that's why this is much more positive here, is because this is going off exponentially when this is exponentially decaying. So we're going to get a lot more positive growth here. And then opposite side, this is going to negative infinity, and this is going to 0. So this is going to go off to negative infinity as well. So that is your two functions. So now if we take sine, hyperbolic sine, and hyperbolic cosine, there should be an x sitting there, like that. This would be tangent, just like before. And then if you reciprocal the sine, you get cosecant, hyperbolic cosecant, and if you reciprocal the cosine. So these are all just the same as before. So those are the two you want to focus on. And then using the combination of them, you create the other 4 hyperbolic trig functions. All right, so we end up with these graphs. We just saw the hyperbolic sine, hyperbolic cosine, and then there's the tangent. So what we're going to do is look at it and see why does it create a hyperbola. So that's why it's called a hyperbolic function. So let's go back to Desmos. So what we have here is sine and cosine. These are not hyperbolic, but if you remember, sine and cosine together create our circle. So remember, cosine is the x coordinate, sine is the y coordinate. And so they're circular functions, cyclical. They create our circle. So as sine goes through, the value of the cosine is the x coordinate, the value of the y coordinate is the sine, and together they make a circle as you go from 0 to 2 pi. Well, when we're talking about a hyperbolic function, what they're going to create is something else. So what we have here is we have our hyperbolic sine and hyperbolic cosine. So if we treat them the same way, well, that's our x coordinate and that's our y coordinate. So at negative 2.1, right, we would have this as our x and this as our y. What it does is it creates this. So I'm going to go back a little bit to show you. And you can see, what is it making? It's making a hyperbola. So if we take our hyperbolic cosine of 3 and our hyperbolic sine of 3, that would give us 1 point. And then making it negative gives us the other point right over here. So if we look at it with values, you can see that for negative 1.7, we get negative 2.646. That is our y coordinate, and that is our x coordinate. And then as we go through every single x value all the way across, what we're going to be doing with these hyperbolic functions is creating a hyperbola. And that hyperbola is the x squared minus y squared equals 1. I put plus there, that's a circle. Hyperbolas are minus. You can see it here, it's minus. But yeah, that's all it is. So this is why they're called hyperbolic functions. So what we're going to do to get used to this is create some points. So whenever you graph stuff, you just plot, right? Plot points and they make a graph. And that graph has a distinct shape based on the type of function we're dealing with. So we already know how to graph a hyperbola. We would just go 1, 1, 1, 1, make that little box, draw the asymptotes, and then in this case it opens in the x, so we go boom, 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 and we'll do that at the end. But right now I want to plot some points. So what we're going to do is plug 0 into our hyperbolic cosine and 0 into our hyperbolic sine and see what we get. Okay, so we would get e, let me make this a little smaller, e to the 0 plus e to the negative 0 all over 2. And so that would be 1 plus 1, which is 2 over 2, which is 1. And we're going to do the same thing with the sine. And so this would become 1 minus 1, which is 0 over 2, which is 0. So our point becomes 1, comma 0. And so let's plot that. So that is one of the points. Now, like I said, one side is the positive for cosh, and the other side is the negative for cosh, the hyperbolic. So all we have to do is look at it and go, okay, well, if that was 1, then this would be negative 1, and that was 0, it stays 0. So now we also have this point. And so you can see it's already forming our hyperbola. So now let's try it again with 1. So if we plug in e to the 1, you end up with this, which is e plus 1 over e over 2. And when we do our hyperbolic, we get 1 minus, well, that's going to be 1 over e again, and 2. So each of these will give us our decimal, which will be our x and our y coordinate. So if we plug them in the calculator, we get 1.54 and 1.18. I'm just giving a round answer here. So we have 1.54, 1.18. So if we plot those, it's 1.54, so a little bit and a half, and then a little bit above. So right there. So you can already see we're creating our hyperbola. And then if we have that one, we know we have to have the negative as well. I put an extra 1 in there. So we plot that one. 1.54, 1.18, we'll just mirror it right there, and so we have that. And so, if we look at our graph, you can see at 1, we have those 2 points right there. So you can see it's forming our graph. So there's the 2 points that we plotted here, and then that one, and they just come from whatever values we're getting from it. So if we continue this process and we plot the next one 1.22 and so on, it will form our hyperbolas. And if we plot the negative values as well, you can see it's going to give us negative 1.175, 1.543, and then we do the negative version of it. And if we keep doing that forever, it makes our hyperbola. So that's it. That's what is our hyperbolic function. So we can graph this by hand like we did before, and that would be making our little box. So we know our A is 1 and our B is 1. And then we do our little horizontal, or not, they're not horizontal. They're asymptotes based on that, the b over a. In this case, it's just a nice clean 1. Just go through the little squares. And then you would just continue this. So we approach it, and you can see that is our hyperbola. So this is why they get the name hyperbolic functions.